So dear students, now let's get into experiment number 9 of section 1 IAVOC 305. That is, we are working with embedded systems and there is Arduino Uno. Now in this particular experiment, our objective will be to interface an ultrasonic sensor. So such type of ultrasonic sensor is actually available just in a modular form. You can see here, this is the ultrasonic sensor module. This you can find, this is a clock crystal oscillator. All right, it is inbuilt into that. Next you can see there are some ICs over there. I will discuss a bit on them during the explanation with the manual. Now importantly, you can find here there are 4 pins: ground, echo, trigger and VCC. Definitely there is no problem with the VCC and ground pin. VCC should be connected to 5 volt and the ground should be connected to ground of the Uno board. Now what this echo and trigger pin is, let us try to understand. You see here there are these two objects. One of them is ultrasound transmitter. That means whenever we apply a trigger signal, you see these are the 2 pins. This trigger pin is connected to the transmitter and echo pin is connected to the receiver. So whenever we give a trigger signal, remember we just cannot give any sort of triggered signal. There is a specific pattern that we have to follow. Whenever we apply a triggered signal, and ultrasound is generated. Now this ultrasound will be traveling. The point is, since it is an ultrasound, we cannot hear it. Okay. Now this ultrasound will be traveling and it will be, if there is any object in front of it, any hindrance in front of it. So we can think like this, that this is the module and here is an object. All right. So what will happen? The sound will get reflected from the object and then it will be received by the receiver. So when it will be received by the receiver, then a signal will be generated at the echo pin. Now we have to apply the Arduino Uno to generate the trigger signal so that an ultrasound is emitted, and if any signal is received back to the receiver, that we have to read from the echo pin. And then we can apply simple mathematical formula that total distance covered by this ultrasound is time taken into velocity of sound. So that will be the total distance covered by the ultrasound or the ultrasonic signal that is emitting from the transmitter. The point is that if you simply consider the total distance covered, it is the distance that the sound travels from the emitter to the object, then object from object to the receiver. So if you want to determine the distance, you need to simply divide the total distance covered by 2, because you are interested in finding out the distance between the emitter and the object. So therefore, in our case, when we make the measurement with Arduino, we get the to distance and the from distance. Therefore, we need to divide it simply by 2. That is the basic funda behind this sensor. Now you see what we will do. We will use the same sensor, okay, that we have connected in a breadboard in order to facilitate our physical connections. and this we will be connecting to the Arduino. Let us now get into the manual and see what is there. So here our objectives will be to connect the ultrasonic sensor to the Arduino, read the sensor value and convert it to length. Now this is an important concept, that we need to read the sensor value and we have to convert it to length. In our earlier experiment, we have converted the signal that was received in a potentiometer wiper terminal to the voltage value. Now this is a different object in which we are to convert it to a length. Remember here that we will not be using an analog pin. We will be using a digital pin itself. That's the beauty of the program. Now you see finally what is the length or the distance that we will be looking into the serial monitor. Okay. So the components that will be required by us is the desktop and laptop, definitely whatever you have in your vicinity for programming the Arduino, then the Arduino Uno board itself, the USB cable, simply the ultrasonic module, and we need jumper wires. Now you see that this is the ultrasonic module that is actually used for this experiment. I have given you here the idea. Okay, the transmitter sends the ultrasonic signal, it is getting reflected by the object, it is getting reflected and finally it is received at the receiver. That is the whole story. Now let us get into the basic characteristics of this. You see here there are 4 pins as we had already discussed. Pin number 1 is VCC, then there is a trigger pin, there is the echo pin, and finally there is the ground pin. Now these symbols that show you the important characteristics. What is the detection range? You can see it can detect from 2 centimeter to 450 centimeter effectively. Now you can see at an angle of 15 degree. What does that mean by angle? You can see here the angle means it is not like this. Okay, completely objected in straight line path. It is something like this. So this angle is 15 degree. All right. And then you can see that its current consumption is lesser than 2 milliampere, and resolution, that if an object, it's nearing an object. So what you can do is that you can think of one of the simple application, that you are putting it on an unmanned vehicle, maybe a robotic car, and you are moving it like this, then it is reading the distance continuously. So what is the resolution of that reading? It is 0.3 centimeter typically. Okay, its power supply, you have to apply 5 volt DC. Its normal quiescent current is less than 2 milliampere. Working current is you see 15 milliampere. Now what is difference between working current and quiescent current is, when it is working it requires 15 milliampere, but when it is in idle status then it is less than 2 milliampere. Then you have got effectual angle, already I have told it, 15 degree, less than 15 degree. The distance range I have given and the resolution also I have given. So now one important point that you have to remember, that the trigger input pulse width. In order to give the trigger, you have to apply a signal, okay, whose pulse width is 10 microsecond. Please remember, you should not commit any mistake. So if you think that I will simply go for a pulse of maybe 1 microsecond, 2 microsecond or 5 microsecond, because sir you had asked to give a pulse, I have given it. It is not going to suffice, you need to have a pulse width of at least 10 microsecond, then only this module will work. Now you see here I have given a very basic description of the board. If you look at the back range of the finder, that means the uh, back part of the board, then you will find that there is an IC, that is there is a IC called this MAX3232. So this is the mother IC that controls the transmitting transducer. That means the transducer, that is the ultrasonic device that is transmitting the signal, it is ultimately divided by this MAX 3232. Now there is a comparator IC also, LM324. I request all of you to go to the datasheet of LM324 Max 3232, especially this LM324. This is a very beautiful IC in which there are 4 operational amplifiers embedded onto the same chip. Now, this particular IC is nothing but a comparator. A comparator is an electrical circuit that actually compares between two signals. What happens actually that when the signal is coming back to you, when the Arduino will understand that there is a signal or not. You see, that is the operation of this LM34. It is continuously checking for an incoming signal. That is, its input is actually at the receiver module of the sensor. So one is the transmitter module, other is the receiver module. So this LM324 is connected to the receiver module. You see here that whenever a signal is generated at the receiver, then LM324 it checks it with a reference value. If the signal that is coming back to the receiver is more than the reference value, it understands that yes, there is an object and that signal is passed to the Arduino. So whatever this receiver is reading, it is not directly given to the Arduino. Remember, it is ultimately actually compared with this LM324, the incoming signal, and if LM324 finds that it is strong enough to be sent to the Arduino, yes, then it is sent. Now it's very important that you understand this timing diagram. It is of very high importance. You see here, you have to trigger. That is, you have to make the trigger pin high for 10 microsecond. You have to make the trigger high for 10 microsecond. And remember, the total time period of a high trigger signal, and this is next high trigger signal. So this high trigger signal and the off time, that is the on time and that is the off time. Remember, that should be at least something more than 50 microsecond. Something more than 50 microsecond. So if you are continuously giving 10 microsecond signals, that might give you some faulty result. Now you see, whenever we apply this trigger signal, what happens? There is a 40 kilohertz acoustic burst. That means an ultrasonic signal of 40 kilohertz is emitted. And you can see there is a precision 1, 2, 3, 4, likewise 8 pulses that is generated at the transmitter. So whenever there is a triggered signal, these 8 signals of 40 kilohertz frequency that is transmitted from the transmitter. Now if there is some object, this signal is reflected back. This signal is reflected back. Now you see what is the output of the echo pin. You can easily find that this distance, your acoustic signal is sent and it is received. In between this, you get the propagation delay. Propagation delay. That means that if suppose the object is situated at a further distance, then what will happen? If the object is situated at a further distance, then this reflected signal will be received somewhere here, because in the x-axis you have got time. It will be received somewhere here. So when it is received somewhere here, then the propagation delay will start from this point. It will go up to that point, then it will go down. Simply. Now this is what we have to do. So here I have given the distance, concept of distance, that is the speed of the sound, total time taken divided by 2. I have already explained this concept. I request that you go through the text, and if you get across any problem, kindly comment in the YouTube channel. Now you see here, this is the circuit diagram I have given here, the connection diagram, very simple, where you have to connect the echo pin to D2, that is the digital pin 2 of Arduino, and trigger pin to digital pin D3 of the Arduino. The VCC is connected to 5 volt. The ground is connected to ground. There is no doubt in that. Now you see here we have given the strategy to develop the code. Now you can find here that for each of the lines I have given the explanation. Remember that similarly you have to write for all the programs. That was actually your first assignment. Okay, so here I hope you have understood, and now I don't want any delay in your assignments. Alright, so I will get into the code directly and I will try to explain that within a short period of time. You can see here that first of all we have defined this eco pin 2. That means the eco is connected to pin number 2 of the Arduino. Then we have to define the trigger pin. It is connected to pin number 3 of the Arduino. Then you can see there are two, I should say, variables. One is duration and other is distance. Now you see duration, this duration is having the data type long. Remember, this long duration is not just a word. Lamba duration, this is not the thing. The long is a type of data. Long is a type of data and the duration is the variable. Duration is the variable. Next comes distance. You see the distance we are taking as an integer value. The distance we are taking as an integer value. Now comes the setup part. Since we are to look for the distance in the serial monitor, we have given serial.begin 9600 is the baud rate. Then we have defined the pin modes. The two pins we have used is, we have named them eco pin and trigger pin. That's the definition we have already given. So you can see that trigger pin is an output pin and eco pin is an input pin. So in order to declare the output pin or the input pin, we have used the pin mode function. Now this is all about the void setup part. Next we have gone to the void loop part. You can see initially what I will do, digital write. So I will write something to the trigger pin. What I will write? I will write a low signal. Why I have written the low signal? Because I have simply tried to ensure initially the trigger pin is at low status. You can see the trigger pin is at low status. Okay. So that is what we have done here. Trigger pin is at low status. After that, I have given a delay of 2 microseconds. So you have seen here that it is delay 2 microseconds it is given. So that's 2. If you do not use microseconds, you can simply write delay within bracket 2000. Next comes digital write. Now you see here we have used the digital write to give it low status. Okay. Now you see that I am here giving a digital write to the trigger pin to give it a high status. Now why high status? Because you see here that I am to make it high. You can see from low it is going for high. Till what time it should be high? It should be high for 10 microseconds. So our next job is to go for, okay, sorry, remember I just committed a mistake. If you write here 2000, it will become millisecond. Since we require a microseconds here, I am not writing here purposefully not 2000 but delay microseconds, because here we are to generate delays in microseconds. So kindly omit that of my word. It should not be 2000 but it must be delay in microseconds. Okay, so for how much time I have to write it high? For 10 microseconds. So you have seen that it is delay microseconds 10. Now after that I am to make the digital pin, that is the trigger pin, low. Why I am to make it low? You can see back that here it should go high. For 10 microseconds it should remain high and then it should be low. So same thing we have done here. There is nothing rocket science here. So high, for 10 seconds it is retaining the high condition, then it is coming to low. Simple. Now you can see this duration. Duration was a variable. So how we are measuring the duration? There is a new function, pulse in. Pulse in, eco pin high. Pulse in, eco pin high. Remember, this is one very important function. Pulse in, what does this pulse in means? The pulse in means that this echo pin. Till what time the echo pin was high? Till what time? So the moment the acoustic burst is out of the transmitter, you can see the echo pin becomes high. And when the signal is received, the echo pin becomes low. We are to measure this pulse width, and that is actually measured by this pulse ln. Sorry, yeah, this pulse in. Okay, echo pin high. For what duration? It is high. So that's why we are using this pulse in. Then comes the distance. Simply, we have to multiply the duration with 0.034 and we have to divide it by 2. Once the distance is there, we have to serial print the distance in order to define the distance, or sorry, I should say display the distance word. I have used here serial print distance within the inverted comma. Then I have displayed the variable value distance. Then I have given in centimeter. Okay. So since it is centimeter, we have made this change, that is 0.034, okay, in centimeter. And after that we have given a delay of 1 second. Here 1000 uh, value is there, that means 1000 millisecond, that means 1 second. So this is all about the thing. You can see here code. And not now what I will do, I will connect the I will make the physical connections. So for that I will be taking the Arduino board. I will remove the earlier connections. Okay, so I will take it. I will be taking necessary connections. So remember that you should be very careful while making the connections. There should not be any mistake. So for VCC, this is the VCC. You can see this VCC. I have connected it to VCC line. That I will connect to 5 volt. So you can see here, I will put some light maybe onto that. I am connecting it to 5 volt. Okay, so that is connected to 5 volt. Next I am to connect the ground. So I will be connecting the ground here. So I will be connecting the ground. Sorry. Next, you can see you should be careful about the pins that you are using. I will be opening the code. So this is the sketch for ultrasonic sensor that we had already discussed, in which you see the echo pin is connected to pin number 2. So you can see this is the echo pin. Adjacent to the ground is the echo pin that is connected to pin number D2. This is pin number D2. I will connect it here. And finally, I will connect the trigger pin that is adjacent to the VCC. That I will connect to pin number D3. Be careful while connecting the pins, because many times it happens that out of just carelessness we make some wrong connection, and then we get surprised that why results are not coming. So here it is, and you can see here the circuit is ready. You can see the white pin, it is connected to the VCC. This black pin is connected to ground. Remember that echo pin is connected to pin number 2. Echo pin is adjacent to the ground pin, and this trigger pin is adjacent to the supply. Now let us try to compile the program. First we will verify it. Compilation is done, everything is very clear, yes. And so it is done with the compilation. We will upload to the Arduino. We have uploaded it. And now you can see this is the thing, and I will try to put some object. So let's this be the object, and we will go for serial monitor. I will put this as object and I will get the serial monitor. So you can see tools, then serial monitor. Now you can see here the distance is 2 centimeter. Okay, you can see the distance. Now I will make a bit. You can see the distance is 8 centimeter right now. Okay, you can see it is 8 centimeter. I will take it a bit further, and you see here the distance is increasing, 13 centimeter, 12 centimeter, like that. So that's all with this experiment. I hope you have enjoyed the session. For any confusion, kindly write back to the comment section in the YouTube link. Thank you.